Students, this is another important concept that we will have to know, which is formation of quadratic equation from the roots. And the form of the quadratic equation is given to be in this fashion: x squared negative of alpha positive beta times x positive alpha into beta. So this is the form that we will have to use if we are given the roots and we are expected to obtain the quadratic equation. Now let me give you an example. So this is an example. Now in this example we are expected to form the quadratic equation if 5 and negative 2 are its roots. So we got alpha to be as say 5 and beta is negative 2. So therefore sum of the roots alpha positive beta is 5 added with negative 2, which is going to be equal to 3, and the product of the roots is 5 times of negative 2, which is equal to negative 10. Now we are going to be using this system, so therefore the form of the quadratic equation is going to be x squared negative sum of the roots alpha positive beta is 3, place that and place the variable x, followed by the product of the roots alpha into beta is negative 10. So if you were to rewrite this, we would get x squared negative 3x negative 10. So this is the quadratic equation that is formed. In fact, since it is an equation, we will have to equate it to 0. Probably we can state the solution. Therefore the required quadratic equation is x squared negative 3x negative 10 is equal to 0. So that is the solution for this question. Now let me just do one more question. Form an quadratic equation given that 2 and negative 1 over 2 are its roots. Okay, so this is a simple question. So we have got alpha is equal to 2 and beta is equal to negative 1 over 2. So I am taking the sum of the roots alpha positive beta is 2 added with negative 1 over 2. So that's going to be 4 negative 1 over 2, which is 3 over 2. And the product of the roots alpha beta is 2 times of negative 1 over 2, which is negative 1. So therefore the required quadratic equation is of the form x squared negative of alpha positive beta times x positive alpha into beta is equal to 0. So this is the required that we are aiming at. So we now have x squared negative of alpha added with beta is 3 over 2 times x positive of negative 1, which can be rewritten as, so you got this 2 here, so I'm going to multiply it throughout by 2. So this would give me 2 times x squared negative 3x, and since I'm multiplying by 2, this is going to give me negative 2 is equal to 0. So this is the required quadratic equation. So I hope you understood this concept, students, and I'm sure you will be able to handle other questions also of this fashion. Let's do this question, students. Find the quadratic equation with rational coefficients and it is given that which as 1 over 3 positive 2 times root 2 as a root, right? So this is one root. Apparently we have been given the root to be in this fashion, so we need to rationalize this. So solution, let alpha be that root 1 over 3 positive 2 times root 2. I will rationalize it by multiplying the numerator by 3 negative 2 times root 2 divided by 3 negative 2 times root 2. This is going to be 3 negative 2 times of root 2 divided by 3 squared negative 2 squared, and the root 2 into root 2 would give me 2. So this is going to be 3 negative 2 times of root 2 divided by 3 squared is 9, 2 squared is 4, 4 times 2 is 8. So 3 negative 2 times root 2 is my alpha. Now since we are dealing with the root of this fashion, the obvious root, therefore beta is going to be, if this is going to be 3 negative 2 times root 2, my other root beta is going to be the conjugate of this. So it's going to be 3 positive 2 times root 2. And that's the way the roots work in this fashion. So we got the alpha and we got the beta. So therefore alpha positive beta, we need to take the sum. So 3 negative 2 times root 2 added with 3 positive 2 times root 2. Negative positive gets cancelled, giving me 3 added with 3, which is going to be 6. And the product of the roots, 3 negative 2 times root 2 multiplied with 3 positive 2 times root 2. This is going to give me 3 squared, negative 2 squared and 2, 9 negative 8, which is going to give me 1. So therefore the quadratic equation is going to be x squared negative of alpha positive beta times x positive alpha into beta is equal to 0. So this is the required quadratic equation. So if I were to write the values, x squared negative of alpha added with beta gives me 6 followed by an x, and alpha into beta gives me 1, which I need to just simply place here and then equal it to 0. So this is the final solution for this particular question. Let us wrap this section on obtaining the quadratic equation from the roots with this question. So the question is, find the quadratic equation given that negative 2 positive I being one of its roots. Okay. Now you should know that whenever you're talking about complex roots, they occur in conjugate pairs. So let alpha be equal to negative 2 positive I be the root, and the other root beta is going to be the exact conjugate for this. So it's going to be negative 2 negative I. So this is the root for beta. So therefore clearly you can sum it up. So alpha positive beta is going to be negative 2 positive I, negative 2 negative I, positive I negative I gets cancelled, giving me negative 4, and alpha times beta, which is going to be negative 2 positive I being multiplied with negative 2 negative I. So this is going to give me negative 2 squared, positive negative negative, and I squared. So this is going to be 4 minus I squared is going to be negative 1. So when you add up you get 5. So the quadratic equation, therefore if you were to write the quadratic equation, this is going to be of the form x squared negative of alpha positive beta times x positive alpha beta is equal to 0. So this is the quadratic equation. In this case alpha added with beta is producing me negative 4. So I need to place the value over here, negative 4. So minus 4 times x, alpha beta is going to give me 5, which can be rewritten as x squared positive 4x positive 5 is equal to 0. So this is the required quadratic equation for this particular question. Now you can literally check this out, you know. So if I were to use the quadratic formula, let me show you that to you. My b is 4 here, but it's negative b, right? So it's negative 4 plus or minus root of b squared is 16, negative 4 5s are 20 divided by 2. So if you were to solve this, this is going to give me negative 4, right, which can be rewritten as 4i squared. So if you were to take the root of it, this is going to be 2i plus or minus, this is going to be negative 4 divided by 2. So if you were to reduce the roots, let me use this space here. So this is going to give me negative 2 followed by positive I, that's going to be one root for the positive side. So for the negative side, negative 2 negative I divided by 2, right? I mean negative 2i divided by 2, and that's would obviously will get reduced because of the presence of the 2 in the denominator. So clearly you can see that these are the roots that we have produced. See, negative 2 positive I is one of the roots given, Obviously we have extracted the other root, negative 2 negative I, and that is how we extract the roots given the quadratic equation. So that completes this section on our study, students. We'll move on to the next one.